Good morning, good afternoon, good evening. We are back and better than ever. We are jamming to our good friend Ashley De La Rosa of The Voice and Windermere Preparatory School. And she is a big fan of mathematics and a big fan of inverse variation, which we are indeed discussing today. So let's get this party started, shall we? Inverse variation is a second type of variation. Remember, we just discussed direct variation. And the biggie here is that as one quantity increases, the other quantity decreases, and the other way around. With direct variation, everything increased together. Well, with inverse variation, as one increases, the other decreases, or as one decreases, the other increases. Okay, and they do a nice job here with the example of the formula we know, distance equals rate times time. And if we solve that formula for time, dividing both sides by r, then we get time equals distance over rate. And if we fix the distance at 100 miles per hour, or 100, I'm sorry, fix the distance at 100, we get the formula t equals 100 over r. So let's see just a quick graph what that would look like if we had rate here and time here. Okay. So let's see, with 100 over r, if we were going 100 miles per hour, the rate would be, let's see, let's do 100 here. 100 over 100 miles per hour, the time would be 1 hour. So time would be 1. Okay. At a rate of, so that's going to be this ordered pair right here. At a rate of 50 miles per hour, 100 over r, time would be 2. So it would look like that. At a rate of 25 miles per hour, right here, then let's see, what would that be? It would take 4 hours. Okay, so you can see that as the rate increases, the time decreases. This graph is heading down. So that's what direct variation looks like on a graph. Okay, so we have our standard or our general form for an inverse variation relationship. If a variable y varies inversely with a variable x, then y equals k over x. And again, k, just like in direct variation, it's the constant of proportionality. And we only have 2 examples here. It's pretty straightforward. The illuminance I of a light source varies inversely as the square of the distance. Well, I'm going to always start with the general form of inverse variation, y equals k over x. Okay? The illuminance I, so I'm going to replace y with I, is of a light source varies inversely as the square of the distance d. So that's going to be k, my constant of proportionality, over d squared. So I have my relationship right away. If the illuminance is 80 units at a distance of 5 meters, determine the equation that expresses the relationship between these two. Well, in order to express this relationship, I have to find k. That's the only thing that I need to find. Okay, so how do I do that? Well, they give me that the illuminance is 80. That's equal to k compared to a distance of 5 meters, so that would be 5 squared. Simplifying, 80 is equal to k over 25. 5 squared is 25. So now I need to multiply both sides by 25. And I do that because the 25s can cancel. Okay, so 25 times 80 equals k, so I'm going to say that 2000, which is 25 times 80, is equal to k. Now, just because we have found k, we have not answered the question. They're saying determine the equation. Well, this is the equation. I just needed to find k. So now I can rewrite this equation as I equals 2,000 over d squared. And that's my equation that expresses the relationship between the illuminance I and the distance d. Okay, one more example. Suppose y varies inversely as x. Well, I'm not going to suppose it. I'm going to take your word for it. So that's going to be y equals k over x. If y equals 9 when x equals 12, determine y when x equals 4. Well, this is what they're asking me to find here. Determine y when x equals 4. Well, if I knew what k was, that would be easy. I would just take k and divide it by 4. Well, I can find k with this previous information. I know that if y equals 9, okay, so I'm going to go down here, y equals 9 when x equals 12. So that's going to be k over 12. Well, now I can easily solve for k. Multiply both sides by 12. The 12s cancel out because 12 over 12 is 1. 12 times 9 is 108. And that is equal to k because k times 1 divided by 1 is k. So now I get to play a little Pac-Man and do some substitution, replacing k with 108, and I get y equals 108 over 4, which means that y is equal to 27. 108 divided by 4 is 27. So when x equals 4, y equals 27. All right, hope you enjoyed it. Loved listening to a little bit of Ashley D. I am out.